So, guys, up there, 2.3, college prep math today. We're going to be doing some things with linear functions. In fact, we're going to be modeling linear functions today. And I guess what I'd ask here is someone to, first of all, look at our essential question and ask what we're trying to answer here. Volunteer to read that for me.
How can you use a linear function to model and analyze a real-life situation?
Okay, so linear function. What do you guys know about linear functions? Should know. That's a straight line. Okay, straight line, that's one thing. Any forms that you know? Slope-intercept form is one of them. We'll look at some more here in a little bit. We'll get you refreshed on some things, okay? So, Jaden, thanks for reading that. Things that we need to accomplish to answer this question up here. We need to be able to write equations of linear functions using points and what? Slopes. Jaden mentioned slope-intercept form. A y-intercept might be like a point, and then a slope is just simply going to be a rise over a run. Okay? So I think we're in pretty good shape here. And then we're going to find lines of fit and lines of best fit, and I'll show you how that works here, okay? Okay, so a line of fit. Anybody know what a line of fit is? All right. I'm going to kind of jump around here in the notes here a little bit. How many of you have heard of a scatter plot before? What's a scatter plot? If you had to describe a scatter plot to me, what would you say? It's a graph of a bunch of... Yeah, I'm going to write this down here. Scatter plot is a graph of a... It's a graph of points. Okay, and when we model stuff, we typically model stuff in the first quadrant. Okay? And what they end up kind of looking like here is this. You might have a graph in the first quadrant that looks like this, and you might have some points that do this. Okay? Now, are those points going to all connect to form one straight line? That's my question. Yeah?
I was just going to say line of fit and line of best fit.
Okay, so hang on to that thought. I'll get there, okay? So how about scatter plot right here? Anybody agree that this is not a straight line right here if I would connect all those points? Okay? But what we do is we use these points to approximate things. And what were you going to say, Xavier, on about the line of fit and the line of best fit?
Well, the line of fit is just like if you make a line from the bottom of the thing, like the beginning, and then to the end of it, that's a line of fit. And like the line of best fit is the one that's like the best like fitting for the...
So if I understand you correctly, there can be multiple lines of fit that might approximate this data for you, but there's one line that's actually the best for us. Is that okay? So a line of fit is kind of like an approximating line. I'm going to put it in here like this. It's a line that can be put in a scatter plot. A line that can be put in a scatter plot to model data. It's a line that can be put in a scatter plot to model data here. All right? Ooh, that didn't work out the way I wanted it to. That's all right. So if I understand you correctly, if I go down to this data right here, are you saying right here, Xavier, that, I could put a line in here like this that would say, maybe be right around all these points like so? Now, does that line hit all the points? Or is it pretty darn close? Is it an approximation to all the points? Okay. So the line of best fit then is going to be the line that's actually... It's the one line of all the approximations that you could put in there that would be your best fitting line, okay? And we're going to talk about line of best fit. We're going to find that line of best fit today. It's going to be the how do I want to say this? It's the line that is the best, and I know I'm going over on this box a little bit. You can if you want, but you don't hold. The line that is the best approximation of the data. Okay, and what I'm going to tell you guys is this. When they talk about finding the line of best fit, this is where we're going to use our online calculator to approximate that, all right? That's where we're going to use an online calculator to approximate that line of best fit. And then once we get that line in there, we're going to use that line of best fit to make predictions beyond the data that's given to us in a scatter plot. So I'll show you what that looks like here in a second. Okay, so I'll give you a second to get that down. Okay. Anybody ever heard of correlation coefficient? Correlation coefficient is called an R value. Okay. And what an R value is this. Let me draw a sketch up here on the board for you guys. Two scatter plots. Here's the first one. Here's the second one. Now these two scatter plots that I have up here on the board, kids, which one kind of indicates a line that's much closer to all the data than the other? The top one or the bottom one? Top one, okay? So what we say is this. We say that this has a strong positive correlation coefficient, meaning this. All those points are really close to that line of fit, aren't they? Now, do these show, is this a good line of fit for the second graph right here? Is this a pretty good line of fit for all the data? Is it kind of in the middle of all of it? But what's true about the distance that the points are away from my line of fit? Are they really close, or are they a little bit further away than we are in example 1? Okay, so we would say that this is going to have a weak positive correlation coefficient. And here's the deal. You're going to be asked about correlation coefficients. They're an R value. They range from, the numbers you're really concerned about are 1, 0, and -1. Okay? So you're going to see this in your calculator today. If you have a value that's really close to +1, if you have a value really close to +1, that means that you have a strong positive correlation. Okay? When I talk about positive correlation, is this graph increasing or decreasing up here, kids? Is this an increasing graph or decreasing graph? It's increasing. So when you have that +1, that indicates to me that that's an increasing graph. Now anything that's close to 0 or around there is going to have no correlation. It means, you know what, there's really no line of fit for the data because the data is all over the place. And we can't really see a pattern with the data. All right? Anybody want to guess what -1 is going to be? Not weak. If +1 was strong positive, what do you think -1 is going to be? Strong negative value, okay? So what we're looking for are values really close to +1 or really close to -1 to indicate a good correlation. I would say 0.85 and above is pretty good, all right? Most teachers are going to tell you 0.9 and above. And I think that most of the examples we look at, we're going to be in pretty good shape, all right? And I'll show you what this means in a little bit. If you ever have anything around 0, what's that mean? There is no what? Correlation. Okay, or the data is just not related. And I'll show you what that means here in a second. Okay. All right, you guys have heard of slope before. You should be able to rattle this off. You've heard it since 6th grade probably.
Rise over.
Rise over. Okay, so remember that. You guys recall slope-intercept form? Y equals mx plus b. We'll put that formula in there. We're going to look at some examples here in a second. What's m represent? M is the slope. B is your y-intercept. Very good. Okay, and then point-slope form. Anybody recall that one? This is the one that I wish kids would remember more often, because this one actually works better. All right, here we go. Let's put it this way. Point-slope form. Y minus y1 equals m times x minus x1. And we'll look at an example here in a little bit. Anybody recall that one? How many know they've seen that before? Okay, and we're going to work with that a little bit today, okay? A lot of vocabulary up there. Are you guys all comfortable with the words that are up there? Vocab that's up there? Okay, well, let's just jump into this. Page 2. Anybody need more time here? Xavier, you got it, bud?
Yeah.
Okay, anybody else need more time?
Okay.
Good?
Yeah.
Anybody else? All right. Well, guys, at the top of page 2, core concept. Let's just run through this real quickly. I'm going to kind of blow this up. There's opportunities when you're given a slope and what else, kids? Okay. If that ever happens, use slope-intercept form. So you might be given information like this. They might say slope is 2 and the y-intercept is 6. Okay, how are you going to write an equation if given that information? If the slope's 2 and the y-intercept is 6. How are you going to write a linear equation for that? This should be reviewed. Say it one more time, Jaden. Okay, so y equals 2x plus 6. That would be the linear form right there. Good. Okay. Next one then is given a point that's not the y-intercept and a slope. All right. If you're given a point and a what? Slope. Here's what you want to do. So somebody give me a point. Any point. 6 comma
22.
22?
Yes.
All right. Somebody run a slope by me then. Any slope. 2. Good. I like 2. Okay. If this is the information they give you, is this point going to be on the y-axis or not? 6 comma 22. Is 6 comma 22 going to be on the y-axis? No, it's not. So it's not like this. You're not given a slope and a y-intercept. You're given a slope and a different point off the y-axis. So if that's the case, if that's the information they give you, this is what I want you to use. I want you to use point-slope form. Y minus y1 equals equals m times the quantity x minus x1. Here's how this works. Okay? Point-slope form, you're always concerned about plugging 3 values in. You're plugging in a y1 value, you're plugging in a slope value, and you're plugging in an x1 value. Really, what you're doing here is saying, well, I need to put in the y value of the point that I have. I need to put the slope in, and I need to put the x value of the point that I have in there. So help me, kids. Here you would have y minus, y1. Okay, what is the y value of the point that's given? 22. That will equal your slope, which is, what's going in for m? 2 times the quantity x minus x1. So x minus. Okay, and again, we should know this. I just want to quick recall this. So if you're given a slope and a point, that would be your equation. Probably be a really good idea to simplify that and get which variable alone. not x, but want to get the y alone, okay? Help me distribute on the right. We have y minus 22 on the left. This would equal, on the right side, what would that simplify to? 2x minus 12. So how are you going to get y alone now, kids? So this will be y equals what here? Negative 12 plus 22. Good. Okay. So if you're given a slope and a point, what form do I want you to use here, kids? What do we call it? Point slope form. Very good, Rhett. Okay. All right. And then given 2 points. Okay. And we didn't talk about this much. You might want to go back to the first page here quickly. Go to your slope down here where it says rise over run. There's also a formula for slope. Your slope is equal to y2 minus y1 over x2 minus x1. Okay. Again, you should have seen that before. You should know that. So what I'm going to tell you to do in this next example is this. If you're given what here, kids, to write an equation for? 2 points. The first thing I'm going to tell you to do is this. Step 1. Do y2 minus y1 over x2 minus x1. All right? That's the first step. Okay? So, I don't know. Maybe I have the following points. 1 comma 4 and maybe, I don't know, 6 comma negative 6. Okay? I consider this up here to be 0.1. So this is like x1, y1 right here. I consider this to be 0.2. So this is like x2 comma y2 right here. So if I was finding the slope of those 2 points, what would go in for y2, kids? So my slope m would equal negative 6 minus y1 right here. What's the y1 value? 4 over x2 minus x1, which would be what minus what, kids? 6 minus 1. All right, help me crunch some numbers. Negative 6 minus 4 more up top. Negative 10. How about the 6 minus 1 on the bottom, kids? Okay, so what's negative 10 over 5 reduced to? Or divide out to be? Negative 2. Good. So my slope's negative 2 here. Okay? So once I know the slope's negative 2 right here, kids, and I know I have an x1 and a y1 up here, what form should I go back into to write the equation in? Point slope form. So let's point slope form our way through this. Okay? So this is going to be y minus, whoops. This will be my value y minus y1. Okay? Okay, y minus y1. What's the y value up here, kids? 4. That's going to equal my slope that we just calculated to be negative 2. And then times x minus what? Yeah. All right, I'm not going to go any further with this, but you guys can simplify that now. So if I give you 2 points, find your slope, and then go back to point slope form. Okay? That should all be reviewed. So hopefully we've got that core concept in there. Again, what kind of equations are all of these if I was to graph them now? What family of functions are we really focused on today? Slope intercept form, and all those graphs are going to be what kind of graph? Linear, absolutely. Everything's linear today, okay? All right, let's talk, kids. Everybody have what they need right here? All good? Okay, I need to put a point on this graph. So right here, I want you to put this point over here. We're going to call a 7, 24.5 on this graph. So maybe put that in there first. All right. How about I volunteer to read example 1 where we're asked to write a linear equation from a graph? Anybody want to read that for me? Okay, person, I'll read it. The graph shows the distance Allison hikes in X what, kids?
Hours.
Hours. So X is going to be labeled hours down here. It says, write an equation of the line and interpret the slope. How long does it take Allison to hike? What's the word here, kids? 14 miles. So if X is hours, that means Y has to be what, kids?
Miles.
Miles. Okay. So here's the deal. It says, how long does it take Allison to hike 14 miles traveling at the same rate? It says, interpret the slope. Okay. What's my definition of slope again? Rise over run. Remember that, okay? All right. First of all, do we know any other point on this graph? If I hike for 0 hours, how far have I gone? I've gone nowhere. Okay? So what point is this really going to be down here, kids? 0, 0. So guys, is it true to say that the y-intercept is equal to 0 here? Are you okay with that? Y-intercept 0, right? Okay. How are you going to find a slope here, kids? Couldn't I do the y2 minus y1 thing? If this is 0, 0 down here. So what minus what first? Right? Y2 minus y1 up top. What minus what on the bottom? Okay, so you get 24.5 over 7. What's your slope, kids? What's the slope? Somebody divide that. 3.5, okay? So an equation I end up with here, kids, is this. Equation I end up with is y equals 3.5x plus 0. Okay, what's the y-intercept in this again? Well, 0. It says interpret the slope up there. What do we get for a slope? 3.5. What's this 3.5 mean, kids? Well, if I think a slope is rise over run, how is my rise unit labeled? How is my run unit labeled? The slope then is comparing a rise of miles to a run of hours. So if we get 3.5, that means 3.5 what?
Miles.
You are traveling 3.5 miles per hour. Okay? So 3.5 for my slope represents you're traveling 3.5 miles per hour. Now, the question says, how long is it going to take Allison to hike what? 14 miles. Take a look at where we labeled miles. Is miles related to the y-axis or the x-axis?
Y-axis.
So would 14 take the place of y in my equation or x? Would 14 take the place of y or x in my equation? Yeah, it would take the place of y. Very good. So I'm going to go ahead and say, well, if I want to know how long it takes her to go 14 miles, plug it in for y. There it be. Somebody solve that.
4 hours?
4 hours, you bet. Thank you, Gabriel. X is going to equal 4 hours. Beautiful. Right? Woo-hoo. Let's get a little more complicated here. Modeling with mathematics. Kelly and Kim are both babysitters. Kelly charges a flat fee of what? You drop your kid off, no matter what. Right when you drop it off, you've already paid how much money? $10. This is like how much you start with. Plus what, guys? $6 per 2. The table shows a total hourly fee for Kim. It says, who charges more per hour? Okay, how much is Kelly charging per hour? Kelly charges $6 per hour. That's like comparing an hourly value to a dollar value. That's like comparing a rise and run. So really, just think of this. Anytime you see a rate, like miles per gallon, or miles per hour, or dollars per hour, or price per pound, anytime you see a rate is always going to be a slope. In fact, I'm going to write it down here. Rate is always a slope in these types of problems. Okay? Today, I drove the law-abiding citizen speed of 55 miles per hour. I'm comparing miles and what? Hours. That's a rate. Yesterday, I went to the grocery store. I bought steaks for $8.99 per
Meter.
dollars per pound. That would be true. If I could get steak for $8.99 per meter of steak, I'm all over that. That's a good deal. All right. I'd have to get a bigger grill, though. All right. So anytime you see a rate, think what, kids?
Whoa.
Anytime you think flat fee is always like a y-intercept. It's like a starting point. All right. Okay, Kelly's charging $6 per hour. Look at Kim's table here. Every hour that passes here, $22 went to what? Went to. Every hour the price goes up by how much?
4.
So what's the hourly charge at Kim's place? $4 per hour. Hey, what if there were 0 hours, like showing up? Just show up at 0 hours. If I continue this pattern backwards, 22 minus 4, what would that be? Wouldn't that be $18? Isn't there an $18 flat fee for her? Show up, all of a sudden it's $18, but you'll have to pay $4 more per what? Well, hour. Okay, so whose fee is more per hour? Who charges more per hour, kids? Kelly does. Okay, right here, Kelly does. Okay. Next question says, how many hours must Kim and Kelly babysit where their fees would be exactly the what? We want to know, when does Kelly's fee equal Kim's fee? Okay. So let's talk about Kelly first. What's Kelly's slope or rate, kids? So this is going to be like y equals 6x plus the starting fee of what? $10. So what we're going to do, Kelly is modeled by 6x plus 10. Kim would be modeled by, what was Kim's rate? How much did this change each hour? $4. So this is like 4x. $4 per hour. What do we say her flat fee would have been based on this table? At times 0. Show up plus 18. Okay. You guys solve that equation there quickly. 6x plus 10 equals 4x plus 18. And tell me how many hours when their fee will be the same.
4.
X is 4 hours. Yep. At 4 hours, you would pay how much to each person? $34. 4 hours, $34. Think of Kelly up here. What's 4 times 6? 24 plus the $10 fee. You're at $34. Okay, very good. Very good. Let's get into this calculator thingy. X is 4 hours here. All right. This is the part that I think is pretty cool. Okay. Finding a line of what here, kids? Okay. So as the table shows, the amount of fruit used to make a smoothie in ounces and the total cost in dollars. Okay. So everything on the left is going to be X. Everything on the right is going to be Y. Okay. I want to show you how this works. They say, first of all, does this data show a linear relationship? If so, write an equation, a line of fit, and use it to estimate the total cost of a smoothie that is used when making 8 ounces with fruit. Okay? This is where you're going to get into your calculator. I'm not going to make you do this. I'm not going to make you plot this. Go into that calculator that you have open, kids, and we're going to start punching in points. Okay? Now, the way way you do it here is this. What's the first point, kids? 2 comma what? 2.10. And then you just hit return. And then what's the second point?
1 and 1.5.
1 comma 1.5.
Yeah.
Then just keep going through those, okay? So keep going through those. Punch all of them in. Once you have all those points punched in like that, I'm going to get my notes here so I can see the points. And then when you do that, just hit submit data, all right, kids? Let me ask a question. That's what I came up with. I'm going to have kind of what I have up there so far. Okay. Pretty neat little tool, eh? Now I have to be honest with you, there's a part that's a little tricky here, and I'll show you what this part is tricky. But the first question, kids, is this. In our notes, they ask, do the data show a linear relationship? Does that data look like a line of fit or a line of best fit goes in there and it looks like a line would fit some of that data? You would say what to the first question? Yes, it does. Okay? So the next part is write an equation, a line of fit, and use it to do what? Okay, 8 ounces is like what value here, kids? Okay, what's really cool about this calculator is they've kind of done it for you, all right? Right up here, the part that's tricky here is where's the x at, kids? Okay, now I can make you write this whole decimal out, or we can agree that maybe we should just go how many places? 2. So I would probably say y equals 0.51, and they put the x in the back. I don't know why they do that, so be careful on this. Your equation's right here. Or you can look at it this way. They tell you the slope is here and the intercept is here. So they could say y equals 0.51 what here? 0.51x plus about 0.85. Are you okay with that? Okay, so our equation we get for this is y equals 0.51x plus 0.85. So the last part of this, kids, is use that data then to get me a cost of an 8-ounce smoothie. Okay, is ounces an x value or a y value, kids? It's an x, so you're really going to plug 8 in for what? Okay, so y is going to equal 0.51 times 8 plus 0.85. Okay, I don't have a calculator handy, so somebody punch that 0.51 times 8. And then add 85 cents. I think it's $4.93. Somebody see if that's right. Yeah, $4.93, right? Anybody get that? You punching, Maddie?
Yeah, that's
$4.93. Okay, so an 8-ounce one. Hey, I can get an idea. Is 8 listed over here, kids? Is 8 even listed over here in this chart for ounces? It's not. So we could use this information and say, well, this chart is linear. An 8-ounce smoothie would be about $4.93 based on the line of fit that we came up with. Okay? So, here's the deal. Example 4, we already kind of did. Okay? We just did. We used the calculator to take this information, all right, and answer this question. So example 4 is exactly the same as example 3 in terms of what we just did here, okay? Because it says use the linear regression. They're telling you, take this table and come up with it on your own. I'm not going to make you do that, okay? You should know how to do that. Do you understand how to use the calculator? That's my first question. Okay. Hey, I have a quick question here. I'm going to go back to this. I want to show you one other thing because you're going to get asked these questions. So in the calculator, you're going to get asked about if is this a strong positive or what the R value is. Okay. Now right here, this is how you do this. You see the two links right here on your graph? One says correlation coefficient and one says what? Hit this correlation coefficient. You're on scatter plot right now. That's what you have up here. If you hit this correlation coefficient right here linked, I love this. It says the R value is what? 0.98. My question to you then is this: is that 0.98 really close to 1 or way away from 1? Pretty dang close to 1. So I would say that this is a strong positive correlation here. Okay? So if they ask you what's the R value or what kind of correlation coefficient do you have in your assignment that I'm going to send out here in a second, how do you get to that? Well, you click on, it was correlation coefficient. Now, if you want your equation back, go ahead and what would you click here to get back to that equation or scatter plot? Click on linear regression there. That's how this works. Okay? Are you guys comfortable with the calculator? Give me some sort of sign that you're alive right now. Are you comfortable with that? Okay, secondly, everybody remember how to get there? Okay, so I'm going to send out the new online. If you didn't have 2.2 ready to turn in today, make sure I have that tomorrow.